All right, we're going to be looking at the evaporation rates of 3 different substances. We're going to start with something simple like water. Now, notice that the water has O directly attached to the H there. That means it has H bonds, which means that it is superpolar and strong. So if I take a paper towel with water on it and put it on the table there and wait for it to evaporate, because it's so strong and those molecules are so tightly attracted to each other because they are superpolar little magnets, it takes a really long time for this guy here to evaporate. Look how slowly that evaporates. So that guy there evaporates really slowly. Then, for my second one here, sorry, I just got to get this set up. For my second one here, I've got ethyl acetate. Now, ethyl acetate is a dipole molecule. It is polar because of those oxygens that are there. The carbons and the hydrogens don't do anything, but there is a vector going out to this oxygen there, and there's a vector going out to that oxygen there, and those vectors do not cancel each other out, and so consequently, this is a polar molecule, but not a superpolar molecule. So what we've got here then is, for the evaporation, this should not be as strong as the water. So if I take some ethyl acetate and I put it on the counter here, you can see that it evaporates a little bit more quickly than the water does, like so. So that guy here evaporates much more quickly because those molecules are not held together very strongly. Then, over here, you've got cyclohexane. Cyclohexane has no polarity whatsoever. It is just carbons and hydrogens. And so it only has London forces, which are nonpolar and weak. So consequently, when I go to do this guy and check out his evaporation, he evaporates very quickly. I can barely keep it on the table. It evaporates so fast. Look how fast this guy evaporates here. He evaporates right in front of your eyes. He evaporates really, really quickly because he is the weakest substance. I mean, look at that. It's evaporating so fast I can barely keep it on the screen here. So, water. Strongest intermolecular forces, H bonds, superpolar. It evaporates very, very slowly. This guy here evaporates slowly. Slow. That guy there evaporates slowly. This guy here is a little weaker on his intermolecular forces. He evaporates a little bit faster, and by the time that we get to cyclohexane over here, this guy here is London forces, nonpolar, is extremely weak, and because of that, he evaporates very fast over here. So, the stronger the intermolecular forces, the slower it evaporates. The weaker the intermolecular forces, the faster